Hi friends, today is a very important day for all of us because today we are going to revise and we are going to make short notes of the difficult lessons. And at the end of this video, it will be really simple to face the examination and get 100 out of 100 for the science paper. So let's get started quickly. So first, we're going to do some, science part one. This is the science part one book. So first we will complete the plant diversity. So morphological features of flowering plants. That's the subtopic that we are going to discuss. Actually, there are so many morphological features in a plant, and we're going to discuss some difficult things as I told you earlier. So, function of roots and plants. So function of the root is the main thing that we're going to discuss today. It fixed the soil, and also it absorbs water and minerals which are dissolved in water, and that is called as absorption. And also it gives rise to new plants through vegetative propagation. So example, curry leaves and belly, willow. English name is willow, okay, and breadfruit. So these are some types of roots. Manioc, that's a lateral root. Beetroot is a taproot. Carrot also a taproot. Sweet potato is a lateral root. And mimosa, it has root nodules. So small nodules-like structures can be seen in the root system of mimosa plant. So such nodules are known as root nodules. There are microorganisms called bacteria, and these bacteria supply nitrogen nutrients required for the growth of mimosa plant, and root system supplies nutrition for the bacteria which live inside the root nodules. So some plants are katurumurunga, then winged beans, such. So they belong to family Leguminose. Storage root stores food, as we know, like carrot and beetroot, onion, all the things store food. So there are different type of roots. Aerial roots such as orchid, and prop roots such as banyan, and stilt roots such as pandanus. And this is a climbing root, it's beetle. And respiratory roots, in Sinhala we call it as Kerala. So here is a table. This will help you to learn. So prop root, example banyan. The function of the prop root is support the branches. Stilt root, pandanus and rampe, function is support the stem. Area roots, example orchid, functions absorb water vapor from the atmosphere, and some area roots carry out photosynthesis. Then climbing roots, example pepper and beetle, the function is they help to climb the stem by attaching to another stem. And respiratory roots, examples are cardol, Kerala, and the functions are exchange of air with the atmosphere. Storage roots, example carrot, beetroot, manioc, and sweet potato, as I told you earlier. And the function is to store food. Roots with root nodules like mimosa, beans, long beans, winged beans, And the function is that bacteria live inside the root nodules, and they add nutrition to the soil and thus make the soil fertilized. So there are so many functions of the plant stem. The main thing that we should study is a part of a leaf. So here, this is the midrib, and this is the veinlets, and this is the leaf tip. This is the leaf blade. This is the leaf margin. This is the leaf base, and this is pectoral, and these are veins. So it's very simple if you study it as a really in a simple way. So as I think my simple way is to remember, like it's like I'm making short notes in my mind, so it's easy to face the examination. That's how I remember, but not at all, not almost, but you know. So it's kind of like this. As these are the veins, so veinlets are these, and this, as this is the midrib, it's like it's the middle part of the leaf, so it's called as midrib. And here it's the leaf tip, so the tip of a leaf is called as leaf tip, and this is a blade kind of thing, so it is called as leaf blade. And this is the margin of the leaf, so this is known as the margin of the leaf margin. And this is like a base, so this is called as the leaf base. And this is pectoral. So these are veins. These are the two venations, reticulate venation and parallel venation. And compound leaves and simple leaves, these are simple leaves and these are compound leaves. Compound leaves have leaflets and these doesn't have leaflets. So like aloe vera stores water inside the plant, and this acapana, the English word for that is biofilm. So this is kind of producing leaves, like producing new plants. This big leaf is producing new plants. So it has a vegetative reproduction. And let's name flowers. So this is also important. As this is a shoe flower, there are female and male parts in a flower. So the stigma is here in the up, and the stamen divides like this, and these are the petals. The function of the petal is to attract insects and all the things. And petal is the female part. Sepal, this sepal is the green color thing. It's like a leaf. Its function is to protect the ovary. And the stalk holds the flower. So this is the inner part. Ovary, ovules. Ovary means like a place where the seeds are stored. That means ovules are stored. So this is the pedicle, or else we can call it as flower stalk. So sepal is generally in green color, and there are the main function is to protect the flower buds. And also petals are brightly in color, and as I told you earlier, the The function is to attack insects for pollination. And androsium is the male part of the flower, and also it contained a stamen. So stamen has two parts called anther and filament. So stamen divides into two main parts called anther and filament. Those all parts are male parts. And gynosium is the female part. Stigma, style, ovary, all those are female parts. So these are the dispersing things. So it's really simple. All the things: dispersal by water, and by animals, and by wind, and by explosion. So this is the lesson of the energy types, forms of energy and uses. Here I have done a video about forms of energy and uses. You can watch it. The link is given in the down below description box. So this lesson is really simple. There are many types of energy called kinetic energy, potential energy, light energy, thermal energy, chemical energy, electric energy, and sound energy. And next is the acid and bases lesson. So this is also very simple, but the thing is that we should study the colors of acids and bases. Before we go to the colors, we will talk about these indicators. These are the indicators in laboratories: sulfuric acid, nitric acid, and hydrochloric acid. And these are to identify acids, and these sodium hydroxide and potassium hydroxide, these are for to identify bases. So these are some indicators used in the laboratory. And these are the colors. When the indicator has now, indicator is the blue litmus, and name of the indicator, it's like a kind of blue colored paper stripes. So when if we have a blue litmus, the acid substance will turn into red, and the basic substance will not change the color. And when we have a red litmus, acids will not change the color, but bases will change the color. The color will be blue. And when we have pH papers, acids will change the color for red, orange, or yellow, but basic substances will turn into dark green, blue, and violet. And phenolphthalein will change into colorless, that means in acids, colorless, and basic substance, it's pink. And methyl orange, the acid substance is red, and the basic substance, or else the base, is yellow. So acids are the things which are in sour taste, and the bases are in bitter taste. So now to identify that, we can't taste them because they are kind of a chemical. So for identification, we use these kind of indicators: litmus papers, pH papers, phenolphthalein, and methyl orange. So I will tell you an easy way to remember this. Acids means it's like a type to get angry. That means when we eat sour things, we get kind of angry, and And when we get angry, we in cartoons, the face is becoming red. So in blue litmus and red litmus acids, in the acid substance, the color is red. And also in basic, so basic starts with a B letter and bitter starts with a B letter, so BB. And also the color also in BB, that means basic substance tastes like bitter. And when we talk about blue litmus, the color is blue, and when we talk about red litmus, the color is red, color is blue. So uh, in the column of bases, all the things are starting with B, 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 B. And these are the colors for the pH papers. And this light yellow, light green is a neutral, and the darkest parts are bases, and the lightest part are acids. That means 1, 2, 3, 4, 5, 6 are acids, 7 is a neutral, then 8, 9, 10, 11, 12, 13, 14, those are bases. So these are the methyl orange, and this is phenolphthalein powder. So, sorry. Animal diversity. So this animal diversity is very simple, and that means the animals are divided into two main parts called vertebrate and invertebrates. So here we go, like humans are vertebrate because now vertebrate means the animals, the creatures who have backbones. So the creatures who have backbones, for example, human, elephant, frog, all the things. And here the backbone. The creatures who have a backbone is known as vertebrates, and the creatures who doesn't have a backbone is known as invertebrates. So these are vertebrates: skeleton of a fish, skeleton of a frog, and a skeleton of a crocodile, and a skeleton of an elephant. These are some invertebrates: leech, butterfly, beetle, spider, prawn, and snail. So you can see a table which is divided into vertebrate and invertebrates. So this table consists of this assignment 6.2. So when we talk about this static electricity, we will discuss about the scientists, because that's the thing that we are going to mix. So here, this scientist is the scientist who found the static electricity, and that means Benjamin Franklin carried out experiments on lightning. So here is a picture of Benjamin Franklin, and Benjamin Franklin carried out an experiment on lightning. So once he set a kite up to a cloud while there was lightning, a static electric charge in the cloud was discharged to the earth. So we can remember this case like the scientist Benjamin Franklin did experiments on lightning, and lightning is a natural phenomenon consisting of static electricity. And this person, he is also a scientist, William Gilbert. William Gilbert is the founder of the solid amber, and he rubbed the solid amber with a silk cloth, and then he told electric charges are generated on the surface of objects. Okay, when they are rubbed. Okay, so now Benjamin Franklin is the person who carried out uh, experiments on static electric charges, and William Gilbert is the person who told that electric charges are generated when rubbing two objects together. So this light lesson is also very simple, because if I have done a video about this light lesson also, so I will put the link down below in the description. If you didn't watch it, you can watch it also. So let's talk about the sundial for a minute. Now in the paper, if someone asks what is a sundial, you have to write the sundial is a method that ancient people used to measure the time. Okay, like that. So shadows are formed due to light, like umbra and penumbra. And let's talk about the parts of Earth, and also the things that means the more things about the part of the Earth. There are three main parts in the Earth, and that means for an example, we can take the egg. So this egg consists of three parts as in the Earth. So this boiled egg has an egg shell and egg white and egg yolk. Egg yolk is the core, egg white is the mantle, egg shell is the crust. So the place where we live is the crust, and the mantle is here, right here. The yellow color part is the mantle, and this is the outer core and this is the inner core. So actually there are four main parts, but we're going to discuss about the three parts: crust, mantle, and the core. Then core is divided into two parts called outer core and the inner core. And here are the parts of the Earth and the thickness, composition, elements present, then the special information. If you learn this table and if you study this table, the paper will be really simple. So when we talk about the crust, deep bottom of ocean 5 kilometers, then the land is 35 kilometers. Composition is with rocks and soil, and there are oxygen, silicon, and aluminium. And the special information about the crust is it's very thin. It's a very thin layer. And mantle is 2,900 kilometers, and also it consists of solid rocks and molten rocks. There are oxygen, silicon, iron, and magnesium. The special information about this mantle is upper part consists of solid rocks, and due to the high temperature, molten rocks are in the lower part. And when we talk about core, the core is 3,500 kilometers away from the crust, and also upper part consists of the molten iron and nickel metals. That means the upper part is consists of molten iron and nickel metals. There are molten iron and nickel. Those are the elements. So it is easy to remember that molten iron the upper part consists of molten iron and nickel metals. So the elements are molten iron and nickel. So the special information about this core is it has a temperature between 4,400 and 5,000 degrees Celsius. Oh my God. So these are some activities to do, but we have not yet completed all the lessons, but we have discussed the difficult parts of each and every lesson, and hope you all have learned something from this lesson. And till then, let's meet in another video. Till then, bye-bye, have a nice day, and now you are very confident because you can face the exam well.